Hi guys, welcome back. So for this video, I'm going to actually look at sketching things in Turning Point. If you are someone who does not like completing the square, I think you've just broken my heart, because completing the square is my absolute favorite, because I only have to remember to half it and square it. But that's besides the point. It's okay. It's fine. Different strokes, different folks. We can move past it. So let's have a go now at sketching some of these equations without using completing the square. So we're still going to go through and find those x and y intercepts, and we're going to use those to sketch. So let's have a go at this question here. So question 3c, y is equal to 2x squared minus 4x minus 3. Okay, so we don't know completing the square. We can't easily factorize this. So how are we going to go ahead and how are we going to sketch it? So, well, I mean, we can always start off with something simple. Let's start off with the y-intercept, because generally there is usually, for a vertical parabola anyway, there's always going to be a y-intercept. It's only when it comes to those x-axes, if we don't have an x-intercept, where it gets a little tricky. So if you're not sure what I'm talking about, what I mean is, if we were to have some sort of parabola, and let's say we had a happy face parabola like this, right? Those parabolas, they're never going to go below this minimum turning point, and so therefore they're not going to have any x intercepts, even if they have a y-intercept. And similarly, you might have a sad face parabola. My drawing skills are not beautiful, as we already know, and again, it's going to have some sort of y-intercept, but the turning point here is a maximum, and so therefore it's never actually going to touch that x-axis. But for a vertical parabola, whether that be the happy face or the sad face, there is always going to be a y-intercept. So let's go ahead and find that one first. So let's let x equal to 0. So y is going to be equal to 2 lots of 0 squared minus 4 lots of 0 minus 3. So that's a nice easy one. 0 and negative 3. And that's kind of like a linear function too, where that constant on the end somehow always magically ends up being the shift up or down. I wonder why that works out mathematically. I wonder what background is going on there. Okay, so let's go ahead then and let's work out our x intercepts, if they exist. So we have, when y is equal to 0, we've got 0 is equal to 2x squared minus 4x minus 3. Okay, so for this one, like we said before, I'm going to pretend that I don't love completing the square as much as I do, and I'm going to pretend that I don't know what it is, or I'm in the middle of an exam and I'm stressed and I've forgotten, or we could try using factorization. Can't factorize, it's not something that's going to easily factorize. Okay, so the last little thing that I could use is the quadratic formula. So quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'll be honest with you, not my favorite. It's good because, you know, we can chug it in, formula, substitute, answer. It's not very procedural. I don't love it. Let's go ahead and let's see if we can actually get a value for this. So in this case, our a is equal to 2. These are just the coefficients at the front of these letters, by the way. B is equal to negative 4, and c is equal to negative 3. So if we substitute that into our equation for our x-intercepts, we're going to get 4 plus or minus the square root of 16 minus 4 times a times c, so 4 times 2 times by negative 3, all over 2 lots of a. So I'm going to go ahead and pop that into my calculator now. All right, so I just had to simplify it a little bit further before I chucked it into my scientific calculator. I think I just typed something in wrong there. And again, this is the other reason why I don't love the quadratic formula, is because of myself, my personal self. I'm always putting stuff wrong in a calculator. I prefer to be able to just do it and not have to rely on stuff. But of course, calculators are there for a reason. So I do have my two solutions here now. So I've got x is equal to 2.58 or negative 0.581. So now we've got our values, we can go ahead and draw those because we have the y-intercept and we have the two x-intercepts. The other thing that we can get when we've got it in this general form is that we can find the turning point without using the turning point method, without having to use completing the square. And there's a little formula that we use, and this is one that we've seen before. So x is equal to negative b over 2a. And in this case, our value for a was equal to 2 and our value for b was equal to negative 4. So substituting those into our equation now, we're going to get 4 over 2 lots of 2, so 4 over 4. So x is going to be equal to 1. And now that we found the x-coordinate of our turning point, we can go ahead and find the y-coordinate by substituting back into that original equation. So y is equal to 2 lots of 1 minus 4 lots of 1 minus 3. 2 lots of 1, 2. 2 minus 4, negative 2. Negative 2 minus 3 is negative 5. So we have our turning point at 1 and negative 5. So we actually have all the same information as what we did before without having to use any completing the square method. The only thing that you have to remember is you have to remember the quadratic formula and you have to remember the turning point formula. So for myself, I think it's much easier to remember completing the square. I always forget the quadratic formula, which is terrible to say. Anyway, I'll go ahead and sketch this and we'll come back. So I've just gone ahead and used my wonderful friend Desmos again to find that graph, and then I've also just popped in those points just to show you that our method does work. So let's go ahead and let's do another little example here really quick. So scrolling up a bit far now, let's have a go at 3F. Okay, so I've got my equation here. We've got to find our intercepts and we've got to find our turning point. So let's go ahead, let's find the y-intercept first, because again, we know for a fact that this is going to have one. By the way, the reason I know that this is a vertical, like a straight up and down parabola, is because it is just in that general form of y is equal to something x squared. If it was x is equal to y squared, that's when it would be transformed, so it would be sideways. So that's how I know that this is just a regular parabola. All right, so to find the y-intercept, we're going to let x equal to 0. So y is going to be equal to 3 lots of 0 squared, so 0, plus 6 lots of 0, which is 0, plus 1. So there we go. Y-intercept, nice and easy to find. Okay, so let's go ahead and let's find our x-intercepts now. So our x-intercepts is when y is equal to 0. So 0 is equal to 3x squared plus 6x plus 1. Now, I don't know what completing the square is. I don't know what factorization is. I'm just going to go ahead and use the quadratic formula. So negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so we know that a is going to be equal to 3, just looking at these coefficients at the front here. B is equal to 6 and c is equal to 1. So I'm going to go ahead and substitute into that equation now. Just going to scroll down. So x is going to be equal to negative 6 plus or minus the square root of 36 minus 4 lots of a. 4 times 3 is 12. 12 times 1 is 1. So 36 take away 12 all over 2 lots of 3. Okay, so let's go ahead and finish this off now. So negative 6 plus or minus the square root of 24 over 6. So I'm going to pop that in my calculator and come back with the answers. All right, so we've got negative 0.183 and negative 1.816 as our two x-intercepts. I've just written those points below. So we've gone ahead, we found our x and our y-intercept, so we can check that off our list. Now we're going to go ahead and we're going to find that turning point. So it's our last little key feature. So x is equal to negative b over 2a. I think the reason that I don't like it is because when I was at school, we didn't get formulas or anything really in exams, or at least not that I remember. And so we would always have to memorize things ourselves, and I never could remember any of those formulas. And I was someone who was actually pretty good at maths. All right, so we've got x is equal to negative 1 for one of our formulas. For our x coordinate. So let's go ahead, pop it back in the original expression to find our value for y. So 3 lots of negative 1 squared plus 6 lots of negative 1 plus, running out of space there, plus 1. So that's just going to become 3 take 6 plus 1. 3 take 6, negative 3. Negative 3 plus 1 is negative 2. So our turning point is going to be at negative 1, negative 2. So let's go ahead and sketch that. And again, I'll just use this using Desmos. And there we go. So we have our two x-intercepts. I think I had negative 1.83. That's all right. That's just probably a rounding error. I had my y-intercept at 0, 1. And I had my turning point at negative 1, negative 2. Let's do one more And I want to pick one that is not the same type as what we've been doing previously. I think the last one I might actually pick 3E. Sorry that that's kind of going out of order now, guys. But just because this is different to the previous examples that we've done. So the thing that's different, we don't have this C term on the end here. So again, let's go ahead, let's work out our y-intercept first. So y-intercept when x is equal to 0. And so for this one, when we have, well, 0 plus 0, our y-intercept is actually just going to be equal to 0. And again, usually this C term here is what our y-intercept is going to be. So in this case, because the value of C is 0, our y-intercept is also 0. Let's see if this has some x-intercepts. Now, x-intercepts is when y is equal to 0. And I'm just having a look here. Now, because I don't have another term added on the end here, I can actually factorize this. So if I factorized out, I could factorize out the 2, and I could factorize out the x as well. So we have y is equal to 2x times by negative x plus 6. So if I was to expand out those brackets, I would end up with negative 2x squared plus 12x again. And so I can now use my null factor law. So my null factor law is when I have two factors multiplied together and one of them will be equal to 0. So either this one will be equal to 0 because 2 lots of 0 times by anything is going to be 0, or negative x plus 6. If that's equal to 0, then 0 times by 2x. That's going to make that 0 as well. So we're going to have two possible solutions. So we're going to have x is equal to 0 as one of our solutions, and then we'll have x is equal to 6 as our other solution. And I know it's really tempting to pop in negative 6 because we have a negative out the front of our x here, but keep in mind we would substitute in the positive 6 to get negative 6 plus 6 equal to 0. So just be very careful with those negative values. All right, so we've got our y-intercept at 0, 0. We've got our x-intercepts at 0, 0, which makes sense because this one will be going through the same point, and also 6, 0. Lastly, let's go ahead and let's work out our turning point, and I have a feeling that this is not going to be shifted too far. So x is equal to negative b over 2a. So this is for our turning point. So negative 12 over negative 4. So x will be equal to negative 3. Okay, so we have our x coordinate now. Let's substitute that back into the original equation to find our y coordinate of our turning point. So y is equal to negative 2 times by negative 3 squared plus 12 lots of negative 3. So let's go ahead and finish this off. Okay, there we go. So we've got our turning point at negative 3, negative 54. So we've got, well, really 3 unique points that we can go ahead to sketch our parabola now. And the other piece of information, just quickly, if we were sketching this and not just popping this into Desmos, I forgot to mention with the last couple, this value, this coefficient out the front of the x squared will tell me whether it's a happy or a sad parabola. And so because this is negative 2x squared, this is going to be a sad parabola. If I just quickly go back just to show you these last couple. So this last one had positive 3x squared, which is why this was a happy face parabola. And then our previous couple also all had happy face parabolas because their coefficients were positive. So sorry I forgot to mention that. So let's go ahead and let's finish off and sketch this in Desmos. Alrighty, there we go. So we've got our turning point at 318. Oh, what have I done wrong? I've made a mistake somewhere. I'm going to have to go back and fix that. Oh, that's what I've done wrong. Good thing that I'm paying attention here. So x should be equal to positive 3. Let's go ahead and fix that y coordinate up. There we go. So I've just popped that positive in instead of the negative. So we do get 318 as our turning point. See, this is why it's always good to double check because even maths teachers get this stuff wrong. Okay, so we've got our point here going through 0, 0, which is crossing over technically the x and the y axis because it is the origin. It does go through both. We have our other x-intercept at 6, 0, which we predicted from before. And then we also had our turning point at 318. So there we go. 3 different parabolas there showing how to do this without completing the square. And again, a little bit more time intensive. I do prefer completing the square, but then again, I am someone who is very practiced at doing that. So if you don't feel that confident using completing the square, I'm very happy for you to use this method for your exam. You're not going to get marked down. Alrighty guys, I'll see you in the next video. Have a good one.